To make the character, starting from the default scene, make sure the cube is facing front, so from the view menu, select front, then middle mouse rotate the scene to get a better view of the cube, and enter edit mode. In the tools shelf to the left, click the loop, cut and slide button, move the mouse over a leading edge of the cube, left click to select, right click to automatically place a center line dividing the cube into two halves. Select one half of the mesh, shift right click and either delete or separate it. Mesh, vertices, separate, selected. This creates two independent objects. Exit edit mode, move one of the objects out of the way, or it can be deleted. Select the remaining object and create a linked duplicate. Mesh, duplicate, linked. Right click or press escape to release the object, then mirror this across the central axis, in this instance the X axis, recreating the original cube. What this initial step does is mirror the mesh so that only one side needs to be edited. Any changes automatically propagate across to the duplicate. Go back into edit mode and on the left hand side click the loop, cut and slide button. Move the mouse over one of the vertical corner edges, left click to select, right click to automatically place a center line. Switch selection mode to face and shift right click the lower side and bottom faces of the mesh. Inset this selection from mesh, faces, inset faces, move the mouse inward slightly, left click to confirm the new addition. This is the starting point for the character's limbs, effectively its shoulders where the arms and legs will sprout. Extrude this new element a short distance, so from mesh, extrude region, move the mouse a short distance, left click to confirm. This creates a shoulder region which acts as a buffer between the limbs and the body when animated. At this point the file can be saved. Click File, Save As, type a name, and then click Save. Doing this now essentially creates a restore point that can be reloaded if needed. With the shoulder area in place, right click the outer face of the extrusion and then from Mesh, click Extrude Region again. Move the mouse a short distance from the body of the mesh, left click to confirm. Repeat the process for the lower face, right click select, Mesh, Extrude Region, move the mouse down, left click to set. This creates the rudiments of an arm and a leg. Save the file again, exit edit mode, then again File, Save As, then in the file browser modify the file name to make it unique. Click Save As to create what is in effect another restore point. To aid the construction process, click the Object Properties button, activate Wire and Draw All. This activates wireframe display, making it easier to see edge placement. With the character's basics blocked out, it can now be defined. Click the Loop, Cut and Slide button in the tool shelf, move the mouse over a horizontal edge of the arm, scroll up to increase the number of loops cut, left click to select, left click to set in place. Repeat the process for the leg, adding 2 loops. Once done, save the file with an incremental file name, creating another restore point. Shaping the arms and legs relies on a significant amount of scaling and general manipulation. Switch to Face Select mode, hold down the Alt key and right-click the loop of faces, second row from the body. Switch to the Scale widget, click the icon in the 3D view header, then left-click, hold, drag the Z and Y axes, decreasing the size of the loop. Select the end of the arm and repeat the process, shrinking that down in size, again the Z and Y axes, and once more for the leg, hold down Alt and right-click the loop second from the bottom. Rescale using the X and Y axes, decreasing the size of the selection. With these simple changes, it's now possible to get a better feel for the way that the character will develop. In this instance, the limbs will be relatively thin compared to the rather large cubic torso. Save the file again, modifying the name to create another unique instance. The next step is to alter the position of the leg so that it's splayed out and slightly angled. This is done by first moving the sole of the foot and then selecting the loop that was previously narrowed and repositioning that so it sits a bit further back relative to its original position. Without doing much else, this essentially straightens the back of the leg and creates the wedge shape needed for the foot. For better control, this is typically done using the Transform widget, so select that in the header and selecting individual loops of either edges or faces, which can be individually manipulated into shape. That's Alt right-click to select loops, or used in combination with the Shift key to select multiple loops. For example, selecting the lower arm and the hand to make group-based adjustments to the mesh, in this instance elongating the limbs. Group selections can also be used to make more localized adjustments, for instance selecting the loop in the middle of the hand and then using the scale manipulator to adjust its height and width relative to the arm. This means constantly toggling between scale and transform to change the size, shape and relationship between the selected elements. Continue shaping the arms, selecting edges at the shoulders, switch to scale again and resize. Adjusting both edges at the same time essentially means that they scale relative to a center point, an average center point. For the underside of the legs, switch to vertex, select the vertices, scale and adjust. Much of this process is about selecting individual or limited groups of elements and adjusting those in relation to the rest of the mesh. Essentially, these adjustments should be changing the shape and form of the mesh so that it's not quite so angular. So selecting the shoulder blades, for instance, and adjusting those so that the arm transition into the body isn't as angular as it was originally. This also helps later with rigging and animation. Once the general proportions are set, the limbs can be detailed and manipulated into their final position. The hand needs to be rotated to a forward position, so select the mesh section, switch to rotate, and then use the widgets to rotate around the vertical axis, switch to transform, and push the hand forward into a more natural position. Adjust the elbow, Alt select the loop, switch to rotate to reposition, and check the progress relative to the rest of the arm. And similarly for the leg, where selecting different loops, the foot can be shaped. Selecting vertices and moving those creates the heel. Adjusting the apparent height of the foot by changing the position of the shin vertices. Selecting the knee loop, lowering that to reposition, and using the front and side view, pushing it forward to kink the leg and creating the knee. This will help proper articulation of the leg later on. Continue down the mesh to the feet and selecting individual vertices, use a transform widget and manipulate their shape, creating a flattened wedge shape. Narrower at the back, wider at the front, with a slope towards the toes. Remaining in vertex select mode and using the transform widget, select the individual vertices of the legs and make minor adjustments relative to the final shape. It shouldn't be quite as boxy or angular as its original form. Although these are relatively minor and localized tweaks, it's important to keep the mesh overall in mind as they are made. This helps to better assess their position and location relative to the entire mesh. This is because when changes are made to one element, they can sometimes affect the appearance of others. A change to the back of the shoulders might require a minor adjustment to the front to compensate and round the overall shape. So keep checking against the entire mesh as progress is made to make sure everything is positioned and proportioned. To finalize the shape and position of the arm, select it from elbow to fingertip, Alt plus Shift right click to select loops and additional vertices, and toggle between the transform and rotate manipulator, and alter the position of the selection so the arm is a bit further back with a kink at the elbow. Use scale to adjust the height-width ratio of the wrist. Select the loop to ensure uniform scaling front, back, top, bottom. And then check with the rest of the mesh to make sure everything is positioned and proportioned relative to the entire model. And then save the file. Again, create an incremental instance and save. The final detail to add to the hand is the thumb. This is done by subdividing the leading edge of the fingers. Click the Subdivide button in the tool shelf and moving the new edge back and inwards, creating an indentation representing the thumb. The rest of the hand can then be selected and repositioned relative to the wrist and arm, balancing all the separate elements together as a unit. The hand typically isn't a flat block, it cups and twists slightly. To reflect this in the mesh, select the inner edge of the thumb and move it upwards slightly, the outer edge, and rotate this clockwise a few degrees, move it upwards. Select the fingertip face and rotate that anti-clockwise a few degrees. Check position and placement, then select the back edge of the fingers and lower. Make some final adjustments, rotate or position, and then check relative to the rest of the arm. Adjust the wrists as needed to twist it slightly and the elbow, and then inspect relative to the rest of the model. The toes are similarly created using Subdivide, just off the front edge of the foot. So select and click the Subdivide button in the tool shelf, switch to Vertex mode, and then using the Transform widget, reposition the new element to form a slight peak to create the toes. Although the new element allows for this, it does so by creating a multi-sided face, an N-gon, that is a face that has more than 4 sides. This can create problems where surfaces collapse into each other. To solve this, the face can be broken into individual triangles, mesh, faces, triangulate faces, which are then reorganized and re-optimized by joining the 2 main foot triangles into a single face. Shift right click the upper 2 faces of the foot and then mesh, faces, twist to quad. Make any further adjustment to the toes, selecting the vertices, and repositioning using the Transform widget, always checking their position relative to the entire mesh. It's important to get into the habit of constantly checking the mesh whilst making these minor adjustments. Small though they may be, sometimes these micro adjustments change the way that something appears or feels when considered as a whole. So adjustments are constantly made with the main mesh in mind. For example, if the toes and foot are too small, the character can look unbalanced relative to the whole mesh. At this point, the character's legs and arms are essentially done. There may be some tweaking at future points, but for now, it's possible to move on to a different aspect of development. Toggle out of edit mode, and in the tool shelf on the left, click the Smooth button under Shading. Toggle back into edit mode, switch the selection mode to Edges, and select the edges around the shoulder joint where they join the body. From the Mesh menu, select Edges, mark Sharp. The selection will highlight blue, indicating assignment. Continue on around the mesh. Select the loop of edges around the ankle. Around the sole of the foot. And again, mesh, edges, mark sharp. These edges will also tint blue. What this does is force Blender to draw these lines as hard edges for the purposes of smoothing. To complete the feature setup, exit Edit Mode, go into Modifiers and add an Edge Split modifier. Deselect Edge Angle, this forces Blender to use the edges that are being marked. Toggle back into Edit Mode and continue on marking the main edges around the cube, this time marking the dominant corners. Again, these need to be marked, so from Mesh, Edges, Mark Sharp, completing the first pass at setting up smoothing. At some point during the build process, the mesh will need to be repositioned so that the character's feet stand on the horizontal. To do this, toggle Perspective Mode and into Front View, and then select the entire mesh from Mesh Select All. This may need to be done twice, once to clear previous selections, then again to select everything. Using the Z-axis of the transform widget, pull up to align the feet with the horizontal X-Y axes. If the mirrored half of the character does not immediately update, toggle Edit Mode to force the change. As this is another significant modification to the model, save the file, again creating a restore point by giving the file a unique name. Repositioning the mesh like this serves two general purposes. One, the feet, as mentioned previously, are aligned with the horizontal, but also the origin point of the object remains grounded and at the feet of the character. The object's origin is the small dot at the center of the grid, useful when the character is animated. Continuing on, it's time to add the bandana. Select the vertical corner edges of the torso's lower half and click the Subdivide button in the tool shelf. This splits the front and back face, but not the side. So select those, and similar to the way the foot was treated previously, split those into individual triangles. Mesh, faces, triangulate. Reselect the bottom two face pairings on the front and back of the side, and merge them back together into a standard face. Mesh, faces, tris quad. This does two things. It merges together the faces for optimization purposes in terms of editing ease, but it also reveals an edge that runs around the mesh, which will be put to use next. The height of the bandana is largely established by the original centerline edge loop, so select, and using the transform widget, move it upwards to increase the distance between lower and upper. Next, switch to face mode and select the faces between the upper and lower loop. This is where the previously reorganized faces come into play. From the mesh menu, click Extrude, Region. A new set of faces will appear, synced and moving with the mouse. Right-click or press Escape to release. Then select each face or group of faces per side and move them outwards away from the mesh slightly using the transform widget, creating a protrusion around the mesh, the basis for the bandana. This also produces a number of extraneous faces that can be deleted. Mesh, delete, faces. With the bandana formed, to create the character's eyes, select the front face and from Mesh, select Faces, Inset Faces. The selected face will inset relative to mouse position, so move the mouse towards the selection to decrease its size slightly. Left click to confirm. Use Transform to reposition. Switch selection mode to resize, either using edges or vertexes. To give the eye depth, Select the face just created and extrude. Mesh, extrude region. Drag the face backwards while still selected, or right click or press escape to release, and then use the widget for more precision. The distance this surface is moved backwards should be approximately equivalent to the depth of the bandana itself. For the mouth, an alternative way to create a shape is using the knife tool. Click the knife button in the tool shelf, move the mouse over the inside edge and left click to place a start point. Move the mouse inwards, left click again to place another point, and then draw out a rectangular shape that terminates on the same inside edge with another left click. To confirm, press enter. This cuts a face based on the line drawn using the knife tool, which can now be extruded. So select, mesh, extrude, region. Move the mouse back and left click to set a depth. Using the knife tool has created another n-gon. This needs to be tidied up and reorganized, so mesh, faces, triangulate to convert the surface into triangles, then reselect as paired groups, that is 2 faces per group, and then mesh, faces, tris to quads. Extruding the mouth will again have created a face that's not needed, so select and delete. Mesh, delete, faces. At this point, as this is another set of significant changes to the mesh, save the file and create another restore point. So in the file browser, give it a unique identifier and then save. Looking at the mesh, the eyes are a little high, so zoom in, Alt right click select the loop on the inside of the eye, and using the transform widget, lower the selection so it's closer to the bottom of the bandana. Select the lower faces of the mouth and use the widget to move that upwards. Select the inner faces of the mouth section and similarly use the widget to move that upwards. Because of its awkward position, this may mean zooming in and multi-selecting the shift right click each face to create a group before moving. Check the position relative to the entire mesh and make any adjustments as necessary to either eye or mouth. The final element to add is the character's top knot, so rotate the model round, activate the knife tool clicking the knife button in the tool shelf, and mark out a triangle clicking the 3 leading edges of the top corner. Hit enter to confirm and create, select the newly created faces and extrude. Left click to set a short distance from the head, click the loop cut and slide button in the tool shelf and middle mouse scroll up to add 2 loops. Select the lower loop and using the scale widget reduce the size of the selection, which will make it appear as if the hair is bound together. Manipulating these types of shapes works well front to back, top to bottom, but not side to side, so rotating the views and using the scale manipulator may not achieve the exact shape that's required. In these instances, switch selection type, typically this would be to vertex because it allows greater control, and shape the area one element at a time. Select a vertex, reposition, select another vertex, repeat until the desired shape is achieved. Relative to the rest of the mesh, shapes like the top knot tend to require a lot of scene manipulation, especially for shapes that should have a more organic final appearance. As each vertex is moved and manipulated, constantly reference the rest of the mesh, checking their positions relative to what should be something like an upturned floppy brush or tail. Once done, check over the rest of the mesh before continuing on. At this point, the character is essentially built, so no more significant editing will be done to the mesh. But as a result of the changes that have been done, the smoothing that was assigned previously needs to be updated. So switch selection mode to edges and work around the mesh selecting significant edges now available as a result of the editing that's been done. That's along the top and bottom of the bandana where it meets the lower and upper body, and where the top knot meets the head. Again, mark the selection from Mesh, Edges, mark Sharp, and then select any redundant edges that need to be cleared. As these can sometimes appear spontaneously as a result of editing, check the entire mesh, and then from Mesh, Edges, Clear Sharp. This removes the marking and reverts edges back to their default condition, which is smooth. Select the edges around the eyes, and again Mesh, Edges, mark Sharp. And similarly for the mouth, select the edges around the opening, Mesh, Edges, mark Sharp. Looking at the entire model, it's difficult to assess the smoothing because the edge split modifier assigned to the live half of the mesh has not been assigned to the mirrored copy. So exit edit mode, select the duplicate half, and from the modifier stack assign the edge split modifier, deselecting edge angles. This activates the edge smoothing as assigned to the live half of the mesh. What this essentially means is that although the modifier was assigned to the object originally and duplicated, the property does not always mirror across to other objects and will need to be reassigned. Once the build is complete, whilst checking the mesh, it's not unusual to find certain elements out of alignment. These can be fixed, making manual adjustments to the transform property values. From the View menu, select Properties, select the element that needs to be adjusted, in this instance vertexes, and then type a new value in the Vertex X, Y or Z input field. In this instance, it's ensuring that all the vertices of the top knot align to the 0 x-axis. This ensures both halves of the model align correctly and match down the center line. And again, as a significant amount of work has been done so far, save a restore point. File, Save As, give the file a unique name, and save. Once that's done, next on the list are material assignments. So expand the Properties panel, click the Material Properties button, expand the Material List aperture, toggle into Edit mode, switch to Face Select, and shift right-click multi-select the bandana. That's the faces front, back, side, top and bottom. Make sure to select the inside of the eye, but not the eye itself. That's the back face. In Material Properties, click the plus button to the right of the material list. A new entry will appear. Click Assign, then New, creating a set of properties. Type a new name, in this instance bandana. In Diffuse Properties, click the color sample and change the color. Click or drag the cursor around the color wheel and press Enter to confirm. Check the materials assignment and then repeat. Select the eye, click the plus button, assign, new, type a new name, in this instance eyes, set a different diffuse color, in this instance black, drag the saturation slider to the bottom, then press Enter. Once a number of materials have been assigned, the duplicate will automatically update to reflect the changes. Next, select the face, the front side, and the front underneath. Select the inside of the mouth except the back face. Then add a new material, click the plus button, assign, and then new, type a new name, in this instance face, select a new color, a yellowish or off-white flesh tone, press Enter, assigning the material for the face. Select the remaining faces of the torso, that's the top half and the remainder of the lower, including the underside. Then once selected, check the group and create a new material. Plus, assign, and then new to create a set of properties. Give this a name, torso. Select a color, in this instance a darker red, achieved by lowering the saturation slider once the color has been selected. Manipulate the scene for better access to the limbs, that's the arms and legs. Select the upper leg, including what is effectively the hips, the shoulders. Check the group selection, create a new material, assign, new, give this another name, body, change the color, again adjusting the saturation. Once the color is selected, press enter to confirm, then check the assignment. Select the faces for the foot or boot, including the sole of the foot. Create another material, assign, new to create a set of properties, call this boots, change its color, adjust the saturation to a much darker red, press enter to confirm. Check the assignment, then move on to the next material. Select the upper arm, the lower arm, create a unique material for this selection, click the plus button, assign, then new, rename arms as the name of the material, set the diffuse color, again a darker red, enter to confirm, and then finally the hand. Although it is possible to use the material select option, doing this at the moment selects everything that still has the original default material assigned. In other words, when setting up the materials, make sure to select each segment separately to create an independent material per section. So select the hand, click the plus button, assign, new, type a new name, hands, set a new diffuse color, again dark red, and then check the assignment. All that remains is selecting the top knot using the original material assignment. So highlight the entry in the material list, click this select button, type a new name, top knot, and then change the diffuse color, in this instance to black. Once that's done, deselect everything, toggle out of edit mode into object mode, deselect everything again, and check the assignments, making sure that everything is assigned a material. If not, go back into edit mode, select the surface to identify an errant material assignment, click the plus button to create a new entry, assign, new, type a new name, in this instance mouth, change the diffuse color to black, enter to confirm. This makes sure that every element of the object has its own material assignment. Check the mesh once more, and then save the file, creating another restore point. Expanding the material list, there should be 10 entries, and when double checking their assignment, make sure to deselect any previous selections and that assignments don't include unused or unwanted faces, which are often better exposed switching the display mode from solid to wireframe and then removed through deletion. Mesh, delete, faces. Check the mesh for other obvious signs of misassignments or unwanted surfaces, then remain in wireframe display mode and then check the rest of the material assignments. In the material list, highlight an entry, then click select, deselect, select, and work down the list. Although wireframe does make it easy to see general assignments, the transparent nature of the display mode can make certain selections difficult to discern, so it may be necessary to manipulate the scene to get a better view of an assignment once it's selected and highlighted in the 3D view. Once the assignments have been checked, toggle back into solid mode and then exit edit mode. Collapse the material list and then save the file. Before continuing on, the mesh needs to be checked for unused faces that should be removed. So move the duplicated half of the character to one side, reselect the original object, and from View, click View Selected. This focuses the camera on the selected item and resets the scene's rotation. In edit mode, inspect the inside workings of the mesh, checking for any miscellaneous faces that can be removed, the insides of the top knot that were generated from the extrusion process earlier. This can be selected and removed. Mesh, delete faces. With the inside of the mesh exposed, it's also possible to make adjustments to the smoothing previously assigned. Selecting the mouth, and then from Mesh, Edges, mark Sharp to generate smoothing along the edges. And for the side of the mouth, same again, select, Edges, mark Sharp. Similarly for the eye, select both sides, Edges, mark Sharp, and the back face, the eye itself, Mesh, Edges, mark Sharp. This is easier to do with the inside exposed than it is trying to select it from the outside inwards. Once everything's done, double check, then switch over to the duplicate and check whether the amendments and changes have automatically propagated and the mesh updated. So select the object, focus, view, view selected, check the object for errant faces, enter edit mode, and check edges for sharp markings, focusing on selections where necessary to make these clear. If everything checks out and both halves of the model are clear and free from errors, save the file and create another restore point. Once all the materials have been set up, the next stage is to UV unwrap the mesh. First, in shading properties, activate backface culling. This ensures the mesh is facing the right way, not inside out. And optionally, in object properties, activate wire overlay for the duplicate mesh if not set previously. Select the original half of the character and toggle into edit mode. This activates a number of overlay options, sharp being one. So deactivate, turning their display off to save confusion with the seams that will now be marked. And in similar fashion to setting up the smoothing, work around the mesh and select edges. Initially, the edge loops around the torso where the bandana meets the body, the front and back edges of the upper torso, the edges around the base of the top knot, the back and front edge of the lower torso, the edges around the limbs, front, back and underneath, and then from mesh, edges, mark seam. The selected edges will highlight orange, indicating property assignment. Turning off the display of sharp edges makes this easier to see. Continuing on, select the edges running down the back inside of the leg. Focus the camera using View Selected to make this easier. Select the back inside edge of the foot and the edges defining the sole of the foot except the inside leading edge. For the arms, select the back lower edge all the way to the fingertips, including their back, bottom and front edge, leaving the top edge unselected. Then again mark these selected seams, mesh, edges, mark seam. These again will highlight orange, indicate the property assignment. Then finally select the edges around the eyes. Edges may need to be selected individually rather than using Alt right click to loop select. And mouth, and then again mesh, edges, mark seam. Once this initial collection of edges have been marked as seams, the next step is to generate the actual UV map. To aid doing this, expand the top right view and select UV Image Editor from the editor list. This is where the UV map appears once generated. Clear any active selections, so select, deselect all, then reselect everything, again select and then select all, before then clicking Mesh, UV Unwrap, Unwrap. This generates a UV map which appears in the UV editor. Bottom left, deactivate correct aspect and then remap. This disables a corrective measure used by Blender that has a tendency to distort UV maps, and in doing so it then means any distortion that is present is an issue with the UV map itself and will need to be fixed. For example, looking at the UV map as it stands, it appears as if the UVs associated with the arms are a bit mushed up. To correct this, select the edges to isolate the arms and assign the seam property. Select all, and then rebuild the UV map. This should straighten out and correct the distortion. With an initial UV map generated, save the file and create a new restore point. Once the UV map is generated, the next thing to do is to assign an image. This is done by first creating a texture slot associated with each of the assigned materials. So click on Texture Properties, New, give the entry a name, for example Ninja, set type to Image or Movie. In the Image subsection, click the New button to access the image properties, provide a name, in this instance Ninja, set UV grid as the generated type, then click OK to generate. Scroll down to Mapping and ensure the coordinates are set to UV. And then in the Image Editor, click the Browse Image to be Linked button and select the previously generated image from the list. It will appear in the UV Image Editor with the UV map superimposed over the top. To view the texture in the 3D view, change the viewport shading to textured, exit edit mode and remove the lamp, the scene's source of light, from Object, move to Layer and selecting an empty layer from the pop-up that appears. The texture will then be clearly visible in the 3D view. With the image generated and assigned to the UV map, save the file and create another restore point. One of the particular advantages of using the generated texture to assign a texture initially to the UV map is that it can be changed. For instance, the checker helps to define texture density to make sure that the UV map is as approximate across the entire mesh as possible. Changing it to color grid helps determine which area of the UV map is associated with which area of the texture based on color, whereas assigning a blank image allows the UV map to be distinguished clearly absent the visual clutter of either the UV grid or the color grid. Before finalizing the UV map, a number of properties associated with the object need to be fixed, in particular its dimensions. These should be uniform, but because the cube was originally scaled, they are uneven. However, attempts to fix this now won't work because the object is duplicated. To fix this, the mirrored duplicate half of the model needs to be made unique and effectively detached from the original. Selecting Object, Make Single User, Object and Data, then Selected Object from the pop-up. Fixing the uneven object properties can now be done by selecting the original, Object, Apply, Rotation and Scale. Repeat for the duplicate, so select, Object, Apply, Rotation and Scale. Because the mesh was originally mirrored, this may invert it. So whilst selected, Edit Mode, select the entire mesh. This might mean deselect before reselect. Then in the Shading UVs tab of the tool shelf, click Flip Direction. This will flip the selection so they all face outwards. Once done, select the original object and rebuild the UV map. So switch to Edit Mode, Mesh, UV Map, Unwrap. This will fix any distortion that may have been present as a result of the object data not being fixed. Once done, in the UV image editor, set the selection type to Island, and optionally in Texture Properties, set the color grid as the texture type. Back in the UV image editor, select each of the islands and reposition them to make better use of the available space on the texture. This generally means selecting each island, that's right-click to select, and moving them left, right, up, down to their final position. Press G to initiate movement, and then left-click to set into place and confirm, once repositioned. To aid the process of reorganizing the UV map, each island can be temporarily moved into the workspace, the grey areas surrounding the texture. They can then be reselected and repositioned back into the active texture area, allowing for better management of the scene. The general idea behind doing this is to allow each of the islands a bit more space than is given to them by default when Blender unwraps the map. This is useful for a number of reasons, not least of which is to limit the amount of texture bleeding into different areas of the UV if the image is used at a smaller size. Where elements need to be rotated, once selected, press the R key to initiate rotate, move the mouse a short distance depending on the value needed, and then left click to confirm. Once the adjustments have been made, check the mesh to make sure there are no obvious UV texture disparities. If color grid was mapped to the UV, one obvious problem will be the difference between the two halves of the character, the result of having to make the duplicate a unique object in of itself so the object data of both halves of the mesh could be fixed. With the original object now UV mapped fully, this problem can be addressed by simply duplicating and mirroring the mesh again. So select, Object menu, Linked Duplicate, right click to release, and then Object, Mirror, X Global. Left click to confirm. As before, this creates an exact copy of the original mesh ready for the final step. With the mesh duplicated, before continuing on, save the file creating a restore point. The final step is to use the mesh to bake an ambient occlusion map. Select the original mesh object and in Render Properties, scroll down to Bake, click the black arrow to access the options, set Ambient Occlusion as the Bake mode, activate Normalized and then click the Bake button. If the UV image editor is visible, progress will be shown and displayed on the mesh once complete. This is essentially a basic ambient occlusion map. To be more effective, however, it needs to be rendered relative to the character standing on a surface. To this end, move the original half of the cube that was detached and position it so it sits directly underneath the character. Adjust the rotation properties to get a precise rotation and scale the item so that it's slightly larger than the width and depth of the character. When moving, drop it below the character's feet. There should be a noticeable gap between the sole of the foot and the top of the object. Select the character mesh and again click the Bake button to re-render the map. There should be a significant difference with this re-render where the underside of the character is much darker due to the proximity of the ground plane. Once baked, from the UV image editor, click Image, save a copy. In the file browser that opens, type a name for the image. Select an appropriate file type, preferably lossless, Targa, BMP or TIFF, and then save the file. Blender will pause momentarily before returning to the previous screen. To make the ambient occlusion map more immediately useful, deselect Normalize and rebake the map. What this does is utilize the diffuse color property previously assigned to the materials, baking them into and as part of the ambient occlusion map, the result of which can then be saved from the UV image editor, again using Save a Copy. In the file browser, provide a unique name. Again, select an appropriate format, lossless, TGA, Targa, bitmap or TIFF, and then saved. Once this is done, the image can then be reassigned to the mesh. In Texture Properties, change the source from Generated to Single Image. Then click the File to be Linked Browser button. This opens the file browser. Find and select the file, left click, and then click Accept, top right. Blender will return to the previous scene with the image assigned to the mesh. Double check its assignment to the UV map. In Edit mode, select all, and then in the UV image editor, double check the assignment by selecting the image from the list. And there we have a red ninja character, simple cube character, UV mapped, textured with an ambient occlusion that includes some diffuse colors. Finally, save the file, completing the build process.